Welcome to this lesson. So, in the last lesson, we looked at a new example of how to go about looking at how the Minimax algorithm works and solving the Minimax tree. And we're going to continue with that particular example in this particular lesson as well. So, let's follow the AI player now. So, the first one is the Max player is AI player. So, let's follow how the AI player would play the game. Okay. So, the AI player has to choose the next move it has to make. It'll ask the help of the Minimax algorithm to make that choice, as you know. The Minimax algorithm in turn will create this particular tree, this tree right here, to calculate the final possible state for each of the next move the AI chooses. Okay, so actually speaking, these final states would not be filled from the start. Okay, so it'll just create a tree and then it'll go and start filling it. So you'll understand how that works once we go about it. So all of this happens in code. I'm just depicting it in a diagram so that you understand how everything happens, but this is just for our understanding. Actually, everything is in binary, zeros and ones in code with respect to the computer, okay? So the Minimax algorithm will first see what happens if the AI chooses the left node, this particular node, for the next move, which is a very big question mark right now because we don't know what will happen yet. So let that be filled with a question mark for now. So right now it's filled with a question mark because it's just selecting it and it doesn't know what's going to happen if it does select it. So next, let's see what the minimizing player, that is a human player, can choose. Okay, so assuming that the AI player chose the left turn in here, this one, the human player now has two choices as well. So it can either choose the left node for that, or it can choose the right node. So let's assume it chooses the left node as well. So now there's nothing there as well. So let's fill it with a question mark again. Now it's the AI's turn again. But the good news is the AI now has actual final states to make a decision from. Right? Because it has +1 and -1 in the end state, so it can choose from that. So they are the win and lose states. So the +1 is win and -1 is lose. So great. So obviously the AI is going to choose the move that is going to lead to it winning the game. Am I right? So it chooses the +1, that's the +1 node, and let us take that value and place it in the AI node, that is the node for the max. Okay, so it's obviously going to choose +1 because that's the greater of the two, that's the maximum of the two. So and now let's fill the max node with +1. Okay, perfect. The Minimax algorithm has completely analyzed what will happen in this side of the tree, the first side of the tree. Now let's look for the next side of the tree, that is the right side of the tree. So what will happen if the min node chooses the right side, that is the right child, rather than the left child that it did before? Okay, so the right child. Now again a question mark here because we don't know what the value is going to be yet. So now we are at Max's turn, that is the AI's turn. So AI now has two possible choices as well. It has two nodes to choose from. One is 0, which depicts draw, and the other is +1, which depicts win. So from these two, the AI can actually make a choice because these are actual values. And as you know, it's the max node, that is, this can choose the maximum of these two. So it's obviously going to choose +1 because 0 is lesser than +1. So we're going to fill our max with +1. Okay. So let's write that down as well. That is, let's fill our max with +1 as well. Perfect. So the third level of the game, this particular level 0, level 2, so the third level is already filled and the second level of the game is halfway filled. Okay, so this level is halfway filled. So now let's go up one level because this is the other question mark. So let's go up one level, that is the human player's turn. As you can see, it also has two values to choose from. Both are values that were selected by the AI. So as you can see, this is min and it has two values, so it has to choose the minimum of those two. But as you know, these two are +1, so it's obviously gonna choose either of those, so +1 in here. So it's going to be +1 in our min node because the minimizing player has no choice right now. It has to choose either one and both are the same. So now the Minimax algorithm has completely analyzed what happens when the AI chooses to move to the left node, that is this particular node, for its very next move. The final result is a win for the AI. So the AI can confidently choose this move now because it's either way going to win if it chooses this particular node. Ideally, you can actually stop the Minimax algorithm at this particular point because you've chosen a move that is going to ensure that the AI wins. And that's what a clever programmer would usually do. But the algorithm, there is a Minimax algorithm, it's not created that way. This algorithm prefers analyzing every possible next states and end state for every possible next move so that it can make the very best decision it can make. That is, it can make the optimal decision so that there is no room for doubt at all. Because it needs values in both of the child nodes so that it can choose the maximum value for the AI. Okay, so that way it will know which is the best choice for it. So that's how it becomes unbeatable. It becomes unbeatable because it leaves no room for error. It leaves no room for losing at all. So it analyzes every possible move and it chooses what's going to make it win for sure. Okay. So let's look at what happens when the AI player chooses the right node in its next move. So what happens when it chooses this one? Okay. So right now this is a question mark because all of this is completely filled. But what happens when this is chosen by our AI? So this one. So this is a question mark as well right now because we don't know. And now assuming that the human player would choose this node. Okay. So the left node in our right parent node. And that's also a question mark. But as you know, it has two possible values that it can choose from. So let's go for that. Okay. So this. So right now our max node has two values to choose from, -1 and -1. Since both are the same, it actually has no choice. So it's going to choose -1 by default. Okay, so this is filled. Now, what if our min node actually chose the right one? Okay. What if it chose the right one, this particular one? So this is also a question mark, and this particular max node also has two values to choose from. So let's go for that. There you go. 0 and -1. As you know, 0 is greater than -1. So our max node is obviously going to choose 0. So this is going to be filled with 0. So now both of the max nodes of our right min node is filled. So now we can actually choose a value for the min node as well. So let's do that. As you know, -1 is lesser than 0 and the minimum node is going to choose the lesser of the two. So we are going to have -1 in here. Alright. So now we've come to almost the end of it. So now we have two values to choose from for our root node, that is the AI player, that is the current state. So the current state has two values to choose from, and since it's the max player, that is, since it has to choose the maximizing value, it's gonna obviously choose +1, that is this particular node, because that is greater than -1. So the human player chooses the low state, but our AI player is always going to choose the win state that will make the AI player win. So there you go. Now the AI, whose turn it is now, has two possible states, +1 and -1, and it has chosen +1. So great. So now it'll happily choose the left node, that is this particular node, because by choosing it, it has a higher chance of winning than by choosing the right node for the next move, so +1, right? So let's illustrate what happens when it does that. I'll show you that illustration in the next lesson. I'll see you there. Thank you.